the Kadov bolide and the Kunishek meteorite, cosmic visitors to the Chelyabinsk region in the 1940s. For anyone interested in meteorites and cosmic phenomena over the southern Urals, the famous Chelyabinsk meteor of 2013 was not the region's first encounter with celestial visitors. In the mid-20th century, two remarkable events occurred here. The Kadov or Tepligorsky bolide in the early 1940s and the Kunishek meteorite fall in 1949. Both left their mark in scientific records and local memory, though they never reached the scale of the 2013 event. Below is a detailed story of what happened, the damage caused, what witnesses and scientists said, what studies were carried out, and how these older events are now connected, or not, to the famous 2013 meteor, as well as how the region uses this cosmic heritage today in science and tourism. A brief timeline: April 9, 1941, early in the morning. A bright fireball was seen over the Kadov-Ivanovsky district on the border of today's Chelyabinsk and Perm regions. People reported a dazzling light, a loud roar, and air vibrations, like a passing train. The object was later called the Kadov bolide or Tepligorsky bolide. Local authorities organized searches for fallen fragments, but no confirmed meteorite finds were recorded. The event remains mysterious, a spectacular atmospheric phenomenon, but without recovered material evidence. June 11, 1949, around 8:10 a.m., another cosmic event took place. A bright flash followed by a shower of stone fragments over the Kunishek district of the Chelyabinsk region. About 20 fragments, weighing a total of roughly 200 kilograms, were collected. This was officially registered as the Kunishek meteorite. It became a fully documented fall, studied by geologists and the Soviet Academy of Sciences. Damage and consequences: unlike the 2013 explosion, the celestial events near Kadov-Ivanovsk and Kunishek caused no large-scale destruction or casualties. The Kadov bolide produced strong acoustic effects, thunder, shock waves, frightened livestock, but no confirmed injuries or structural damage. The Kunishek fall left visible material meteorite stones, but it was a relatively low-energy event. Fragments scattered across fields and steppes, exciting both residents and scientists, but without causing disaster. Thus, the cosmic incidents of the 1940s had psychological and scientific, rather than physical, consequences. Eyewitness accounts and local memories: witnesses of the Kadov bolide described a dazzling flash, lighting up the night sky, followed by thunder that made the ground shake. Some claimed to see sparks or fragments breaking off from the main fireball. These reports appeared in local newspapers and were later cited by regional historians. Few official records exist. The event occurred during wartime 1941, when systematic observations were scarce. Locals also recalled a ground trace about 8 meters wide, a sticky, blood-red deposit of unknown origin stretching more than a kilometer. The next day, the trace turned gray, possibly due to chemical reactions, and the snow covered by it melted. The Kunishek fall was better documented. Eyewitnesses saw a smoke trail and heard several explosions afterward. Dead stones were found on the ground. Local authorities quickly involved geologists, and the collected material was sent for laboratory study. Standard procedure for confirmed meteorite falls in the USSR. The meteorite's fall was preceded by the flight of a bright bolide with strong sound effects and shaking of the ground and buildings. It traveled roughly from Sverdlovsk toward Chelyabinsk north to south. The bolide's brightness was compared to the sun. Some witnesses even noticed shadows cast by objects. Explosions were heard across the Kunishek district. According to contemporaries, there were 3 or 4 explosions, then a flash, and a whitish trail remained in the sky. The Kunishek meteorite was smaller and exploded closer to the ground. Some fragments hit farm buildings, and part of it fell into Lake Chelyabinsk. Most witnesses reported that before disappearing, the Kunishek bolide split into 3 parts. Fragmentation occurred at an altitude of about 19 kilometers before it lost cosmic velocity, that is, before the end of its luminous phase. Each fragment formed its own glowing trail, changing direction slightly. 3 large fragments weighing 36, 40, and 118 kilograms were found. The largest lay in the leading part of the scatter ellipse, and later broke apart. Its biggest piece weighed 63 kilograms. An expedition from the Mining and Geological Institute of the USSR Academy of Sciences, led by senior researcher A.N. Igumnov, arrived at the site. In total, locals collected and handed over 15 individual specimens and many fragments, about 205 kilograms of meteorite material. scientific study and classification. The Kunishek meteorite was officially entered into the Meteoritical Bulletin and studied multiple times. It was classified as an ordinary chondrite of group L, petrologic type L6, meaning it is a stony meteorite with low metallic iron content, heavily metamorphosed by heat. Its mineral composition, olivine, orthopyroxene, chromite, metallic comosite and tannite, and sulfides was analyzed using modern techniques such as micro-Raman spectroscopy and electron microprobe analysis. Samples are stored in scientific and museum collections in Russia and abroad. The Kadav bolide, however, left no recovered fragments. Scientifically, it remains undetermined. Only eyewitness accounts and scattered reports exist. No verified samples or chemical analyses were found, so it is known more as a documented atmospheric event than a classified meteorite. Vernadsky's telegram and wartime investigations. The day after the Kadav bolide's explosion, local authorities began searches. From a telegram by academician V.I. Vernadsky, chairman of the Meteorite Committee of the USSR Academy of Sciences, published in Chelyabinsk Worker on April 15, 1941. On the morning of April 9, residents of Kadav observed a bright bolide accompanied by strong illumination of the area, rumbling, and air shaking. Apparently, this phenomenon ended with a meteorite fall. Therefore, the Meteorite Committee of the USSR Academy of Sciences asks all witnesses to report details, the direction of the light and sound, and, if the bolide's flight was seen, its trajectory. These reports will help determine the fall site. If the meteorite has already been found, all fragments should be carefully preserved and immediately reported to the committee. A scientific representative will visit the site, and the discoverer will receive a cash reward. A month later, the newspaper reported, 2 kilometers from the village of Tbilius, a collective farmer named Khrushchev discovered a pit about 1/10 of a hectare in size and 1.5 meters deep. At its bottom and around it were fragments of an unknown gray-brown substance resembling slag. It is assumed the pit was formed by a falling meteorite, the flight of which was observed on April 9. The pit did not exist before. On May 27, a district council secretary, Comrade Semyonov, was sent to the site. The unknown fragments were sent for analysis to the Kadav plant laboratory. The USSR Academy of Sciences planned an expedition for detailed investigation, but the war disrupted all plans, and many materials about the Kadav meteorite were lost. Renewed interest in 2013 interest in old meteorite falls resurged. After the 2013 Chelyabinsk explosion, members of the Cosmopoist group had been collecting data on the Kadav event even earlier, but accelerated their work as amateur treasure hunters flooded the area. In March 2013, researchers visited the villages of Orlovka and Tbilius. There were no living eyewitnesses left, but one woman confirmed her late husband's account. The meteorite's boom was mild and did not wake the villagers. Local historians confirmed the existence of a crater, though reports of strange phenomena like frequent snakes appearing inside were unsubstantiated. Searches in May 2013 found 6 craters, none of which were meteorite-related. A local gamekeeper, Vladimir, said his grandfather had seen a meteorite fall before the war, its trajectory going beyond the mountain ridge. It's possible the crater lies near the village of Veliki Luki, where the aborted wartime expedition was originally headed. Was there a connection to the 2013 Chelyabinsk meteorite? The February 15, 2013 meteorite fall was a global event, the largest airburst since the 1908 Tunguska explosion, recorded by hundreds of cameras. It caused thousands of injuries from shattered glass and widespread damage. Because the Kadav and Kunishek events occurred in the same region, some speculated about a cosmic connection. However, scientifically, no genetic link exists. The Kunishek meteorite was an ordinary chondrite L6. The Chelyabinsk meteorite was an ordinary chondrite L5, chemically distinct. The Kadav bolide's composition remains unknown. Different chondrite groups L versus will indicate separate parent bodies in the asteroid belt. Without composition data from Kadav and given the decades between events, scientists conclude these are geographically coincidental but unrelated. Renewed research after 2013 re-examined old archives and samples including Kunishek's, using new analytical methods focusing on microstructure, shock effects, and isotope composition. None showed any link to the 2013 meteorite. However, the global attention-boosted meteorite monitoring networks, video observation systems, and educational programs in the Chelyabinsk region. Older towns, Kunishek and Kadav, are now often mentioned in lectures and museum exhibitions, as part of the region's cosmic chain of history. Museums, identity, and tourism. The Chelyabinsk region has fully embraced its meteorite heritage. The State Historical Museum of the Southern Urals houses one of the largest preserved fragments of the 2013 meteorite, now a centerpiece of its collection. The region promotes space tourism, themed exhibitions, public lectures, and souvenirs. The Chelyabinsk meteorite is part of small museum exhibits and scientific archives, occasionally displayed in regional natural history exhibitions. The Chelyabinsk is known mainly from local history publications and mentions in Chelyabinsk sightseeing routes. Though no physical samples remain, its story enriches the region's cultural mythology. Scientific and cultural significance for science. The 2013 Chelyabinsk event advanced global meteor and bolide monitoring and rapid data exchange. The 1949 Chelyabinsk meteorite remains an important reference specimen for studying L-group chondrites. The 1941 Kadav event reminds us how valuable systematic documentation can be, even for unrecovered events. For tourism and regional branding, the Chelyabinsk region now uses its cosmic history to attract scientists and travelers alike. The phrase "land of meteorites" appears in tourist materials, blending natural science with local culture. Chelyabinsk and Kadav are included as early chapters in the same cosmic narrative. Conclusions. 1. The Southern Urals have a rich history of meteorite activity. Key events include the Kadav bolide 1941, Chelyabinsk meteorite 1949, and Chelyabinsk meteorite 2013. 2. The 1940s incidents caused minimal physical damage, unlike the destructive airburst of 2013. 3. The Chelyabinsk meteorite is a well-studied ordinary chondrite L6, while the Kadav bolide remains unexplained due to lack of material. 4. No scientific evidence links the three events. 5. The Chelyabinsk region now uses its cosmic legacy to strengthen identity, foster scientific research, and promote tourism.